It's totally up to you how you want to do this, but what I do is I usually like number, I'm just going to go 1, 2, 3, and I'm going to number the equations. Okay. Now, when we get our answer, it tells you at the top that it's called an ordered triple. So it basically looks like a point on the graph, except it's x, comma, y, comma, z. So we have 3 letters that we're going to solve for. All right, so you're going to do 2 equations at a time when you work on this, so not all 3 at once. And I will tell you I would solve this system every possible way you can think of. So if anybody's looking at that system, does anybody have a preference whether you want to maybe try to tackle getting rid of x, y, or like what? Honestly, it doesn't matter. Let's do z. Okay. So if I did z, all right, maybe, do you want to pick 2 equations you want to work with? Okay, why'd you pick those?
Just because there's no number.
Exactly. If you want to work with the z, let's say we're going to tackle that first. I don't even have to do anything to eliminate the z. If I use the second, I'm just going to copy the second and third equation. I'm not going to do anything to either one of them. I'm just going to copy it to the side here. X minus y minus z equals 3. The third equation was 5x plus 2y plus z equals 5. You don't have to do anything. They're already opposites. One's a positive z, one's a negative z. So if I just literally add the bottom line to the top line, we're going to get x and 5x would be 6x's. Negative y plus 2y would just be 1y. The z's eliminate. And then 3 and 5 is 8. Okay, so the only other rule, we're going to basically do 2 equations at a time. So we used equation 2 and equation 3. So you're going to pick 2 of the equations, I'll just write this down, and eliminate a variable. In our lovely case for this example, we picked to do z. So that's your first step. The second step is just to pick 2 different equations. So it just can't be 2 and 3 again. Now the key is here, you have to eliminate the same variable that you eliminated in the first step. So we chose to do z. So I just need to pick 2 different equations. So we could do like 1 and 3, or we could do 2 and 1. We just can't do 2 and 3 again. So 2 different equations. It could be one of the ones we just used, but it has to be, can't be 2 and 3. And we also would have to eliminate, in this case, we did z, so we would have to eliminate z again. Okay, so let me just make a recommendation here. Let me pick, I'm going to have us pick equation 1 and equation 2. And as long as it's different from the first 2, I have x plus 2y plus 4z equals 6. And in the second equation, I have x minus y minus z equals 3. If I have to eliminate z, I can't just do this like I did on the last question, because we already had opposites. But the reason I did pick 1 and 2 is because one of the z's was positive and one was negative, so I don't have to introduce a negative. What would I have to do? I have to manipulate at least one of these equations to get rid of z. What would you, like, can I multiply, I'm not multiplying 4 by anything to get 1, but could I multiply 1 by something to get 4? What would you multiply the second equation by? 4. You don't need to introduce a negative or anything like that. So all I'm going to do is I'm going to run a 4 through the second equation. Okay, so I'm going to just come over here. I'm going to copy the first equation. So just x plus 2y plus 4z equals 6. And I'm going to run a 4 through all the terms and the plain number of that second equation. The goal is to get rid of z. So we're going to turn this into 4x minus 4y minus 4z. I'm trying to make the z's opposites, which we would have there. 4 times 3 is then going to give you 12. Okay, so our whole goal, we picked 2 different equations, but we had to eliminate the same variable. So I'm going to add these guys. Okay, now
x and 4x is 5x. 2y minus 4y would be negative 2y. This is important. The z's cancel, so I got rid of those again. And 6 and 12 is going to give us 18. So the first step, just pick two equations, eliminate a variable. Then the second step, just two different equations, you have to eliminate the same variable. Okay, now the third step is we're going to use the two new equations. So my two new equations, we have the 6x plus y equals 8, and we have the 5x minus 2y equals 18. Basically, those first two steps is taking the system from three equations with three variables. Now I have a system that has two equations with the same two variables. So then this turns into what we've been doing for the whole first half of the unit. So it's totally up to you. I'm sorry, I'm at the bottom of the page here. We can do substitution. It would be easy for me to get y by itself in that first equation, or we can do elimination. Either way, it's totally up to you. If I had given you guys this system on the quiz yesterday, do you want to use substitution or elimination, or we don't care? Okay, which variable would you get rid of? Okay, how would you do that? That's what I would do too. Yeah, you can just, if you want to get rid of y, here's all I'm going to do. I'm going to multiply this line by 2. The y's, you already have one positive and one negative, so the top equation would just turn into 12x plus 2y equals 16. The bottom equation, I'm not going to manipulate that. I'm just going to copy it because the y's are opposites by doing that. Now, 12 and 5, I got 17x, and then on the other side, 16 and 18, 34. I'm just going to divide by 17 real quick. Whoa. And x is just 2. Okay, now the only difference between this and a regular system you guys are used to solving that just has two variables, we're just going to have one more step. So once you get one of the variables, you're just going to do like we've been doing, just back up one step, doesn't matter which one. I'm just going to plug this into that first equation. So I know x is 2. If I plug that into either one of those equations in that system, I just use the first one, I can get the y value. So plugging in 2, I'm going to get 6 times 2 is 12 plus y equals 8. I'm just going to subtract the 12 real quick, and y is going to be negative 4. Now, the only thing that's different, now I've got two of the variables, I just had a third variable, but if you go back any one of the equations in that original system, here I'll tell you what, I can't get this on the page very well. I'm just going to copy the very first equation in the system. The first equation in the system was x plus 2y plus 4z is equal to 6. Okay, now I know x is 2 and I know y is negative 4. So I just plug both of those in, any one of the three equations in the original system. Once you do that, the only variable should be z. That's the only one we don't know. So this guy right here, this would just be 2 minus 8 plus 4z is equal to 6. I'm writing too big. Just combine like terms. 2 minus 8 would just be negative 6. And I'm actually going to add that 6 to the other side, and I'm going to write over here a little bit. So I get 4z is equal to 12, because 6 and 6 would be 12. And then you just divide by 4. So z is going to end up being 3. And I know that's a lot of work, so as long as you have all three variables, you're good. If you want to write the answer what they call an ordered triple, so that's the kind of the order you write it in. It goes x, comma, y, comma, z, so basically just adding a z into the mix. So I would write 2, negative 4, 3 as my solution to that system. And I know, trust me, I know that's a lot. And these can be time consuming. I tried to pick questions that all have nice answers so you're not messing around with decimals or fractions. But just keep in mind there's a bunch of different ways you could do the same problem. You could have maybe started out, maybe you wanted to get rid of y, or you wanted to get rid of x, and our algebra could look totally different, but we would have the same answer at the end of the problem. So it's just kind of
how you want to approach it. But the basic concept, pick two equations, eliminate a variable, pick two different equations, eliminate the same variable, and then you're going to work through a 2x2 system with two equations and two variables, and then you solve that just like we've been doing. We're going to try one more on the back. So this one is elimination. I'm going to show you one on the back that's substitution. Okay. Now, it's really like a preference thing. And in that first, actually, let me go ahead and keep it on this side, but I'm going to flip back to this first system real quick. If you like substitution better, it would be really easy in really any of these equations to get one of the variables alone, and then you could substitute if you wanted to do that. This one on the back is just kind of set up with the first equation being set equal to one of the variables, and in this case I just got x by itself right here. Okay, so if you're going to do substitution with the system, so you need a variable alone here. So first thing is need a variable alone, which I have in the first equation. I have x by itself. And then what you do is you substitute, I'm just going to write sub, into both other equations. Okay, so I'm just going to write this here. So I'm going to substitute this in for x into the second equation. So the second equation, it's 2. Instead of x, we're just going to write that whole thing. 3y minus z, thank you ma'am, plus 6 minus 5y minus z equals negative 2. Alright, and we're going to simplify just a little bit. So a little distributive property. So 2 times 3y, we got 6y. 2 times negative z would just be negative 2z. Really, I try not to confuse the z with the 2 because I think it can look like a 2 sometimes. So try to make sure you're recognizing that as a letter. 2 times 6 is 12. And then we had this minus 5y minus z equals negative 2. All I'm going to do on the left side is just combine like terms. So I have a 6y minus 5y. So I just have one y over here. And I have a 2z that's negative and a negative 1z. So I have negative 3z. And then, let's see, we just have a 12. The only other thing I might recommend real quick there, I would just subtract the 12 real quick. And so then I have like y and z on one side, and I'd have negative 14 on the other side. So I substituted what x was equal into the second equation in the lovely system. And I'm going to repeat that process. So you also have to substitute this into the third equation. So you should do this twice. This third equation is negative x. So this is a little tricky. So if I do negative x, I'm just going to put like a little negative 1. And then I'm going to copy what x was equal to in that first equation, 3y minus z plus 6, and then copy the rest of that third equation. So it was plus y plus 2z equals 7. Now, while we're doing this, we're trying to create a system that only has 2 equations with 2 variables. So when I substitute in for x, we're getting rid of x in each of those 2 equations. So when I get done with this, we'll have 2 equations that'll both have y and z. Alright, now this guy's just going to change the sign, like positive or negative. So this will be negative 3y plus z minus 6 plus another y plus 2z is equal to 7. I'm just going to combine some like terms here. Sorry, maybe I should color these. I've got the negative 3y and a positive 1y. So all total, I'm just on the same side of the equation. This would be negative 2y. I've got 1z and 2 z's here, so I have 3 z's, and then I just had a negative 6, which I would maybe just add to the other side just real quick to make it more look like the equations we've been working with in some of our other systems here. Okay, so by doing that substitution, I had 3 equations, and I know this is long, I had 3 equations with 3 different variables. Now we have 2 equations with the same 2 variables, just y and z. There's no longer an x involved in either one of these. So basically, I'm going to write this to the side. My new system is y minus 3z equals, negative 14, and negative 2y plus 3z equals 13. That's my new system. Okay, now, if you use substitution like I used substitution in my first step, you don't have to keep using substitution. Like, honestly, if it was me, right then and there, I'd be like, hey, I can just cross the z's off with elimination. So just, you don't have to use substitution in every part. If you want to just use it as the first step and then use elimination with the system you get left, that's completely fine, which is what I'm going to do here. Because if I notice, my z's are opposites right now. I don't even have to do anything else. I can just cross them right out. This 1y minus 2y be negative y, and then negative 14 plus 13 would be negative 1. Now, because I had a negative y and a negative 1, what is y actually equal to? If you got a negative on both sides, what's positive y equal to? 1. So the negatives on either side would just cancel out. Like if I divided both sides by a negative there, I just was writing too big. So y is 1. Now I just have to back up like one step. It doesn't matter which equation you use. I'll tell you what, I'm just going to use this one right here. So in this case, you have y, which is 1, minus 3z equals negative 14. I'm going to subtract the 1 from both sides. So I get negative 3z is negative 15. What would z be then? 5. If I do negative 15 divided by negative 3, the negatives are going to cancel, you get 5. And then, I'm totally running out of space, but if you guys look back, you can use any equation in the system. I would maybe use the very first one because that has x by itself. Let me see if I can grab a different color. That very first equation was x equals, I'm looking up here, 3 times y, which is 1, minus z, which is 6, and then plus 6. Those are all just numbers. So this is 3 minus 5 plus 6. And if I simplify that, that'll be my x-coordinate of where all of these would intersect. So I would get, let's see, 4, right? And I know that's a lot of work, and obviously I wrote too big for some of that. But I have all 3 of those coordinates to write it as an ordered triple, if you prefer that. As long as you show me what each variable is, that's totally fine. But x is 4, that would go first. Y is 1, that would go second. And then z is 5, so that would go third if you want to write it as an ordered triple. If you want to just put like x equals 4 and okay, sorry guys. Alright, now let's do one more. Now we had some trouble with our coin question on the quiz yesterday, so let's make sure I go through this really well with you guys. Alright, now, this is going to have 3 different types of coins because we have 3 variables today. So it says a vending machine takes nickels, dimes, and quarters. 40 coins, we're going to get an equation out of that. Value of the coins, $5.30. And then the third equation, twice as many dimes as quarters. Okay, now, number of coins. Nothing to do with like dimes or 10 cents, quarters or 20, nothing like that. Just I have 40 coins. So I'm going to use N for nickel. So my number of nickels plus, I'm going to use D for dimes, my number of dimes, plus Q I'm going to use for quarters. Going to add up to 40 coins. Nothing to do with their monetary value. Okay, now my second equation deals with the money. So nickels are 5 cents. So I'm going to put 0.05 times my nickels. Dimes are 10 cents, so 0.10 in front of my dimes. And then quarters are 25 cents, so 0.25 for every quarter.
and then the total is the $5.30. So money goes with money. What it's worth is going to go with that variable. All right. Now, of course, you do not need to rewrite this. I'm going to do it really quick. So it says twice as many dimes as quarters. Okay, twice as many dimes as quarters. I'm just going to make something up. Let's say I have 10 quarters. How many dimes would you have? I have twice as many dimes as quarters. Let's say I had 10 quarters. How many dimes do I have? Okay, what did you multiply by 2? The amount of quarters. And I know I told you guys this before, but I want to tell you again. This messes people up. So the twice gets multiplied by the word at the end of the sentence. Like it gets multiplied by the quarters, not by the word closer to it. I had a lot of people on the quiz yesterday, like literally just mixed that equation up, and then that messed up their whole system. So the twice goes times the quarters. So I'm going to say dimes equals twice the quarters. So the 2 goes in front of the word at the end of the sentence. All right, now if I was doing this question, I would tell you I would definitely do substitution, because, or at least to start, because this one equation is like a really tiny little equation and it doesn't even involve the nickels at all. So this will help us break this down really quick. So here's what I would tell you to do. Let me do substitution. I'm going to substitute that 2q in for the dimes in both of the other 2 equations. When I do that, that's going to take us, instead of 3 equations with 3 variables, then we'll have 2 equations with 2 variables. So you just got to substitute it in both of those equations. So if I put it in the first one, I would have n plus, instead of the d, I'm going to put 2q plus another q equals 40. So just going to simplify that a little bit. So I have n plus, how many q's do I have? Like if I combine my like terms. 3, right? 2 here, 1 here, so 3 q's. 40. Okay? Now, my other equation, let me grab a different color. We have, this one's a tiny, tiny bit trickier. So I have 0.05 for every nickel, that's the value. Now, I'm going to keep the 0.10 in front of the D for dimes, but in for the dimes, I'm going to put that 2q. And then plus 0.25q, and that's equal to the 530. All right, now I'm just going to simplify this like I did the other one. So 0.05n, I'm just going to take one more step. If you do, this is like 10 cents times 2, right? So just 0.10, like 2 dimes would be 20 cents, right? So this just looks like 0.2, or you can drop the 0 if you want to. I'm going to leave it so it looks like money. And then plus 0.25q, 530. Now here, this is just like adding change, right? I've got 0.05n. This is like 20 cents plus 25 cents, right? Just like 2 dimes plus a quarter. So 20 cents and 25 cents would be 45 cents in front of that Q. 530. Okay, so that was after I substituted into the second equation. This first one was way less work. But now I have 2 equations, and I have the exact same variables. So, here, I'll tell you what, I'm going to write it over here. I'm going to write n plus 3q equals 40, 0.05n plus 0.45q equals $5.30. So now I just have nickels and quarters. Honestly, if you guys like substitution, it would be very easy to get the nickels alone in that first equation, just subtract 3q, and then you could use substitution. If it's me, I don't know. I just kind of prefer elimination, but it's totally up to you, whatever your preference is. I would maybe just, since this has a coefficient of 1, I would maybe just get rid of the nickels with elimination, but if you would prefer substitution, you could do that too. I would just run like a negative to make it an opposite, 0.05 in front of that first equation. So I'd have negative 0.05n, and then, oh, fail, this would be a minus, sorry. If I do 0.05 times 3, it's going to be 0.15Q. And I'm going to grab my calculator real quick. If I do negative 0.05 times that 40, we're just going to get, like, it's going to look like negative $2. The second equation, I'm just copying this, was 0.05N plus 0.45Q equals 530. If I add these guys together, that eliminates the nickels. And then, forgive, this should be negative. So negative 0.15 plus 0.45. This is 0.3 in front of your Q. You have negative 2 plus 530. So this is going to look like 330. And I'm just going to divide that by the 0.3 real quick to get the number of quarters alone. So quarters, we have 11. Now, once I have that, you can start plugging it back in. If it was me, I would actually go right here, because if I know the quarters, we can just multiply that by 2 to get the number of dimes. So if I know that the quarters are 11, just do 2 times 11, so the dimes are going to be 22. And then if it's me, again, I'm going to look, that very first equation just tells me how many coins I have, right? We have 40 coins. I'm going to subtract 11 quarters and 22 dimes, nothing to do with their monetary value, just how many we have. And so the leftover, I'm just using that first equation there. The leftover is 7, so that must mean that we have 7 nickels. And then in terms of an ordered triple here, they probably wouldn't ask you to do anything like that because the letters are not X, Y, Z. They would probably have you just write like nickels 7, dimes 22, quarters 11. But however you want to write it, if you got a word problem, is totally fine with me. Is anybody having a question?